Hi, good afternoon, everyone. It looks like we're waiting on a couple more. Let's give them another minute or two to arrive, and then we'll get started. Oh, there we go. All right, let's go ahead and get started. Maybe she'll join in a little bit. So I want to start off with a few admin pieces that I'm kind of kicking around in my head. And then I would like to chat a bit about where we want to do today. Okay, so first, let's talk about the remaining exam stuff. So we've got one exam scheduled for next Wednesday. And the idea is that this exam would cover the starting with one-way ANOVA, but then ending not with all of simple linear regression, the first half. In other words, if you remember that I did a lecture 10, part 1 and part 2, and part 1 really talked about like the conceptual parts of it as well as how to interpret one. Whereas part 2 was more how to actually perform a simple linear regression. Here we go. So that's the differentiation. That's the cut point there, in other words. So just to make it even more clear, simple linear regression would be fair game for part 1 of the exam, but not for part 2, because I wouldn't ask you to actually run one. So that's the plan. Then we have our third exam, which is scheduled during finals week. And I have two things I want to talk to you about with that. First, I know it's written in the syllabus that it'll be a comprehensive exam, but I'm thinking maybe not. I'm thinking instead it could just cover the last pieces that we haven't covered together. So that would be the second half of simple linear regression, multiple regression, and then what we do going forward with the chi-square and those pieces. I did do that before. I changed it from comprehensive to just covering those last pieces, and it seemed to go well. I feel like that is probably enough. The other choice is we could keep it comprehensive, and we could do an emphasis on those last few pieces just because, you know, you haven't been tested on those yet. So let me put that out there. But my thinking is against the comprehensive, but you know, if you were really looking forward to a comprehensive, okay, I see some agreement regarding that. Okay, yes, okay, sounds good. Okay, so let's just plan on that. Perfect. Then the second thing regarding that exam is it's scheduled to occur. And I just had this memorized and then I went away from it. Wednesday, December 9th, sometime later in the day. Yeah, 6 to 8 p.m. slot. So we can change that as long as, because it's on Zoom, you know, it's fine. It's up to us really. As long as we can all find a mutually agreeable time. In terms of, I'd prefer it stayed Wednesday or Thursday. I'm okay with either of those options. If we could avoid Friday, that would be super. And my only obligation on Wednesday is I have a 3:30 to 5:30 for a different class that I have to do. And then Thursday, I'm relatively flexible. Now, of course, I don't know what your different final schedules look like. But you probably know each other better than I know what's going on with all of you. So if any of you wants to volunteer a time or wants to kind of weigh in here, we can kind of start talking about some times, or I could send around like a Google, one of those Google voting things so that we could determine.
I have an idea. I don't know if it's plausible or possible, but would it be possible for us to like not have it on Zoom and more of like a take home, so we would have like a day or two to complete it as opposed to like just a 2-hour time slot because of timing issues?
I'd rather not do that. That's not really my first choice. I'd rather give you, and I would rather give you, as kind of a nice long time slot to do it, but all in one sitting kind of thing. That would be my preference if we can work it out. So like, is there, like, let me just start. Wednesday morning or afternoon. Do we know are you guys booked up? Do you guys have any availability then?
We have practicum on Wednesdays from 12 to 3.
Okay.
And I think some of us have clinic hours in the morning.
Sorry?
I think some of us have clinic hours on Wednesday morning as well.
Okay, let's look at Thursday then. What's Thursday look like?
I know most of us, I think, are good after. Do we meet with for clinic practicum? Does anybody know on finals?
I have clients Thursday afternoon.
Okay. You have clients Thursday afternoon, and we're talking Thursday the 10th then. Okay, and the morning, it sounded like you all had something?
Yeah, we have class. Could we do, so you said the period is Wednesday 6 to 8. Could we
Yeah.
could we meet at 4?
We could do Wednesday at 4. I have no problem with, oh, wait, Wednesday the 9th. No, that's when I have sorry, that's what, we could look at Friday though. If you want to
Okay.
look at Friday, I'm okay with that.
I know
Is it-
that Friday isn't good for me at all.
Really? Okay. Shoot.
I'm pretty sure we don't have practicum that week, though. I'm going to the syllabus right now, research practicum that Thursday morning. So that would free up most of our Thursday mornings. I don't know about Jenna, but the rest of us are in that class.
Okay.
Yeah, we don't have class that day. Our final papers are due Sunday the 6th, and there's nothing about meeting that week at all on the
Okay, so
syllabus, at least.
So potentially Thursday morning, and does that leave you out, Jenna?
No, I would be good Thursday morning.
Okay. How about we do that? Does that work?
Yes.
Yeah, and I can ask Dr. Gans tomorrow morning just to double check that we don't have class the 10th and then email you.
Okay, perfect. That sounds great. Thank you for doing that. Assuming you don't have class, what time would you like to start on Thursday?
Maybe like 10:30.
Does that work for everyone? Okay. Why don't we say we start 10 on Thursday? And if you find that there's a conflict, let me know and we'll figure it out. But yeah. Okay. Perfect. I think we have something that'll work. So, and I'm sorry about the dogs in the background. We have 2 dogs that were initially getting together perfectly fine and now want to be at each other's throats, and they're both separated right now, but they're still barking like mad. So I apologize if you hear that. It's kind of sad. So we are thinking Thursday, December 10 at 10. Perfect. Okay, so for today, I think those were the main, oh, and then I'll just tell you, for the homework for next time will be due when we come back from the break. Let's have it due not next week, but I don't remember if that's the 4th or the 5th. I can check real quick. But that Wednesday, it's actually Wednesday the 2nd, excuse me. Let's have it due Wednesday the 2nd of December. So that will include the homework that I just talked about on the lecture, and and you can see for the simple linear regression as well as for the multiple linear regression. Remember, you're doing 4 and writing up 2 of them. You're writing up either the B or the A. It was one of those that actually was friendlier for writing up. I'm just checking for you guys. Report B only. Okay, so you're reporting B only, but you're doing both A and B. And I kind of pre-checked the data a little bit to make sure we wouldn't be completely evil. Some of those data sets are kind of evil. So that brings us back to today. And I posted a concept checklist for the test. So we can, we can do a variety of things. We have to go through the 2 presentations. I would be happy to go through a simple linear and multiple linear regression for you. You could go through one, like just getting some practice either in groups or by yourselves. As we talked about before, I could go through one, you could follow along. Oh, RamCloud was down before, but it's back up, so I think we're okay. So those are some options, or we could just go through, you could kind of look through the concept checklist, or this could be an and/or thing too, where you go through the concept checklist and see if you have any questions for me that you'd like to ask. So I guess my main question is, do you want to today either have me or yourselves go through a simple linear and multiple linear regression example? I'm seeing at least one nod.
It would be helpful for me if you went through one.
Okay, if I went through one, yeah, okay, I'll do that then. Why don't we just start with that? And I'll go through a simple linear and I'll go through a multiple linear, and I'll go through how you do it. I can't promise you I'm not going to refer to Laird. I might, but I'll go through how you do one, and then if you have any questions about reporting, we can talk about that too. The reporting for multiple, as you probably saw from the lecture, is going to be very straightforward, because we're not checking any of the assumptions. But simple linear has quite a few assumptions. Yeah, Erin.
So does that mean that the multiple linear regression will not be on the exam too then? It will just be the linear?
Right, and even the simple linear regression, you won't have to do one for
Right.
exam 2, right? You would just have to have some knowledge about interpreting output. So it was that first part. It was basically slides 2 to 49, if I'm remembering correctly from lecture 10, and not slide 50 that actually said, let's go to Laird and look at how to do it all. Make sense? Okay. All right, so I found a data set. I only have 1,000 data sets open. Let me just make sure I have the right one. No, it was not. You were not friendly. It was, yes, this one. Okay, so let me share my screen. I think it's this one. Yes, this is the example I want to show you. Okay, so like I said, I looked at it in advance. I did a little cheating, just to make sure it would be appropriate and we could see things easily together. So let me just give you a little bit of background to this one. Acme Employment Services. I guess we just lost someone. Acme Employment Services wants to evaluate the effectiveness of its Get That Job seminars, which consists of experts facilitating sessions designed to enhance resume writing, job search strategies, and interviewing techniques. After 90 days, participants are surveyed to assess their characteristics and outcomes. Okay, so we have these different variables here. For the simple linear regression, what I'd like to do is treat employment status, and that's how long it takes them to get a job. And it goes from, I believe it's in days. So 0 days to 90 days, and 90 actually is an indication that they did not get a job yet. Yes. So employment status is number of days it took to get a job, 0 to 90, 90, they're still looking for work. Age makes sense, gender makes sense, race makes sense, although there's something I want to talk to you about race. And experience is years of experience working in their current field. Applications is the total number of job applications submitted. Okay. So remember in the video, I talked about sometimes if you have more than 2 categories of a variable, you have to dummy code it out to include it. And you can see here, there's 5 categories for race. So they had to create 4 dummy variables. Remember, you need 1 less dummy variable than you have categories. Okay, so 5 categories, 4 dummy variables. These are just unstandardized residuals. I don't think they're going to get in our way. Hopefully not. I don't know why they included them in the data set, to be quite frank. But what we're going to look at for our purposes is, does the number of applications you submit predict employment status, right? Predict how long it takes you to get a job. And so logically, we would probably think that the more applications you put out there, the quicker you get a job. So the lower this employment status number will be. So we're probably thinking might be a negative relationship, but let's take a look. Okay, so I am going to go ahead and, sorry, give me 1 second here. I just don't want to click things in a different order or do something in a different order than what you're expecting. So, okay. So the first thing we want to do, actually, let me go over to predictions, linear regression. Okay. So first thing we want to do is establish if a linear relationship exists. How do we do this? With the scatter plot. So I'm going to go ahead and create a scatter plot for you guys, and then we'll take a look at it. Okay, so we go under graphs, chart builder. Okay. Oh, I already kind of did this. I'll take it away so I can do it again. How about that? Okay, so we have our x-axis and our y-axis. Remember, the way you get the scatter plot is it'll start off on bar. I don't want to really do that. It'll start off on bar. You go to scatter. You go ahead and bring the scatter, the first one, the upper left one, into the center. And then your x-axis is your IV, which we decided in this case was applications. Applications. Your y-axis is employment status, your DV, or dependent variable. And then you simply click OK. And now I'm going to have to do a new share where you can actually see my output. I'm going to have to move this. There we go. And like I said, I did preview the data and saw that this might be a nice one to look at simple linear regression with. I tried to at least choose one of your problems as relatively friendly in terms of this as well. So hopefully that works out. So as you can see, as we predicted, there is this negative seeming relationship, very nice linear relationship between applications and employment status. So it makes sense. The more applications you put out there, more likely the quicker you are getting the job. And this, remember, as you increase, it means it's taking longer to get the job. So we would expect this to be a negative relationship, and so it is. Okay. Okay. And then I think, yeah, we're just going to jump right into the procedure here. And we're going to check off a whole bunch of stuff. So let's take a look at that. You are seeing my output right now. So let me switch over to the output. Okay, so I'm going to run it from here. I'm just checking this is what you are seeing. Yes, yes, okay. So I go under Analyze, Regression, Linear. Dependent variable, remember, is our employment status. Independent variable is the number of applications. We go under Statistics. We want estimates, confidence intervals, the Durbin-Watson, the case-wise diagnostics for 3 standard deviations. And I'm trying to remember the rest. They don't actually have you do an R-squared change for simple linear regression, which I guess makes sense. So that's all we need here. And then we'll move on to the plots where we'll do Z-resid by Z-predict. Okay. Okay, so we'll continue here. Go on to the plots where we're doing Z-resid, Z-predict. So the Z is just telling you it's a Z score for this. It's, you know, makes it a little bit easier to interpret, at least in theory. And the predictor, of course, goes with X. That kind of makes sense. And if memory serves, you also check off histogram and normal probability plot. Yes. Okay. Then we hit continue. I don't think we need to save or do any options here. No, that's fine. So we just are going to click OK. All right, so there's only one thing we're putting into this model. And when it comes to regression, we like to talk about models. Why? Because we're modeling a relationship. Oh, must have been he got cut off. Okay. So we're modeling a relationship here. Okay. So we can start looking at some of this output. We're looking at, here's our R, very nice healthy R. This is not surprising given what we saw with the scatter plot, right? R is 0.949. The R square is 0.901. And the adjusted R square is 0.900. And if you remember, we talked about the difference in R square and adjusted R square. This one, the R square is more for the sample and the adjusted R square is kind of downward adjusted for the population. Nonetheless, we can still say, because of the adjusted R square, that we are accounting for 90% of the variance in employment status with applications, which is like phenomenal. That's pretty amazing. Okay, so here's our ANOVA. Okay, so not surprisingly, this is significant. That's a huge, huge F. Remember, we report this very much the same way as we would report a ANOVA, a regular ANOVA, right? We just consider this top part the good stuff, the regression is the good stuff, that's like the between, the residual is the leftover, the error, just like the within. And so we would say F of 1, 92 equals 836.586, comma P less than 0.001. And I always say you can click in these and I never show you. Yeah, that's really 5.6941 times with e to the negative 48. So that's a lot of zeros before we get to that 5. So that's really a very impressive significance value. Okay, so great, wonderful. So we can see that part. And we want to move on to look at the coefficients. It's occurring to me I'm doing this in sort of not the same order that Blair does, which is probably not the best, but we'll deal with it. We'll get to everything. Okay, so let me just look at the coefficients since I'm here. I should have looked at some other stuff first. So remember, we don't care too very much about what's going on with the constant. That's our y-intercept. If we're trying to do some prediction, we would at least want to know what this value is, because that would be in our y hat equals ax plus b. No, let me try that again. Y equals a plus bx equation. The a is our intercept that appears on the top here. B is this number here, the applications number. That's our slope, the angle of the line, right? And the slope is negative 2.896. So it tells us, just as we saw on the scatter plot, this is a negative relationship. Okay, and then we have our p-value here, which again, this bottom one, the one that goes with the slope, the one that goes with our b, is always going to match what was in the ANOVA. I know the top one matches too, but that's sheer coincidence. It's really the bottom one that always matches. Okay. So now we'll look at some of the stuff I should have looked at first. I got too excited by the 90% and all that. Okay, so we have some case-wise diagnostics here, and looks like we have a few troubling cases, number 9, number 50, and number 68. And we can kind of see what those values are. And we see that the what the residuals are, right? So we can see that this one is really below and the other two are really above. Okay. Let's see. Here's that. Give me 1 second here, guys. Okay, so I guess we could look back to our scatter plot at this point and find those unusual points and kind of see if we're really worried about them unduly influencing the data. That would be something we could do to deal with those outliers. So we can do that. Let's take a look. Okay, so let's look back to that initial scatter plot. Okay, I can kind of guess where they're coming from. This is probably 1 because it does lie a bit outside. This is probably another. I'm not sure about the third. It might be this one. I could look it up and actually see. But bottom line, I'm not worried about this unduly influencing this. We have a lot of points here. And, you know, I mean, I suspect if I remove this, it would even be a better fit. But I'm not terribly worried about them. But, you know, one could argue that because we have an outlier, we should consider whether, you know, we might do the analysis both ways, kind of like we thought about with, you know, before. We might go ahead and do it with and without the outliers. And then when you get into multiple linear regression, which we didn't really talk about, they actually start talking a little bit more about whether your outliers are truly influential or not. Okay. So I am cheating one more time here. Oh yes, the heteroskedasticity, which we got to check by looking for either our funnel or our fan. So let's look for either our funnel or our fan. And that was a little bit lower here. Here we go. Definitely not a funnel. At least I don't see it. I don't see the fan either. Like I could see potentially an argument for one maybe, but I think that's pushing it too far. I don't see the fan. I would say that's actually okay. And then we get to check for our normality of residuals with our normal PP plot. And yeah, I was wondering about a little bit of negative kurtosis in ours. Let me take another look. Okay, so this part here curves under, and then this part kind of curves above. Maybe there's some of that. Again, I'm not going to be terribly worried about it. Oh, that's actually the opposite. Yeah, I'm not sure I'd be terribly worried about it. I think for the most part it's fine. As you can see, this gets into a little bit of judgment call, which I know is a little bit uncomfortable, but you know, we kind of do the best we can to compare it to the diagrams we have and see if we're matching up or not. Okay, so yeah. Maybe it's more, no, I don't know. I think I would think it's okay. And then we actually went through and interpreted the results. So I think we're okay there. You know, I just wanted to make sure we covered everything here, because we did ask for a Durbin-Watson. And I don't think we talked about the Durbin-Watson. In fact, I'm not convinced I saw the Durbin-Watson. So let me just double check that. Oh, it's right there at the beginning. So let's check that real quick. With the R and R squared, here it is, Durbin-Watson 1.707. So remember, we made this kind of rule that we would say, I think it was, we can go a little below or a little above, like between 1.5 and 2.5 was okay. And beyond that wasn't going to be okay. I think that's the rule we landed on. And this is clearly okay. So I'd be fine with that too. So technically you do want to check your assumptions before you jump into the actual reporting of results like I did. But in either case, we talked through that piece right there of how you'd actually come up and report the result. So the one other thing I just want to say about this before I leave simple linear regression behind and ask you for questions, of course, would be that equation. I just want to make sure you're comfortable with that. So if I said that, what were we talking about? Application and employment status. So we could sub in and say, you know, someone with 30 applications, someone who put in 30 applications, what would be their predicted employment status? And the way we would do that is we would take 90 plus negative 2.896 times 30, which is going to be something close to 90. And that would be, if we added that together, right? The 90 plus negative 2.896 times 30 equals whatever that equals. That would be our predicted employment status, the number of days we would expect that person to take to get a job. And that's one of the nice things about regression, is that you can use it to predict. So we'll go through that equation business one more time with multiple linear regression, but sorry, it's a little bit out of order, but I think I covered everything I wanted to cover for simple linear regression, at least how you'd go through one and how you could attack it and then look for everything. Okay, let me turn it over to you guys. Questions? Feel free to chat in or speak up, whatever works for you. And I'll set up the next one while you let me know if you have anything.
I just have a question for reporting. When you were showing that table before, and I think that the options in the table were, I forget, you looked at the bottom half of the table instead of the top half when you were looking at the different statistics for when you would report. The next
Which,
table, I think a little bit further up. Yeah, here, constant and applications. So what?
yeah.
Yeah, if you can speak a little bit to that.
Okay, so a little bit to the difference between these two.
Yeah, and which one you would report.
Okay. So if you were the main one, if you're trying to use prediction, you need both, right? Because we need the 90.196 plus 30 times negative 2.896 to get our prediction. However, if we're trying to understand if we have something important and significant in the model, all we need really is that bottom one, because we don't care too much if our intercept is significant.
Okay,
Does that make sense?
yeah, thank you.
Okay, of course, yeah. Any others? Okay, all right. So for the next one, and you can continue the chat in, I can, come back around or do whatever. I'm gonna go ahead and get rid of this output. Well, maybe you want it, so, okay, I'll leave it. We'll just go ahead and move on. So let me go back to the data. Here we are again. And now we're going to do a multiple linear regression. So if you remember for multiple, one thing we can do is we can include both continuous as well as dichotomous variables. And so employment status remains our dependent variable. That's what we're trying to predict, how long it takes them to get a job. We're going to use age. We're going to use gender. Age is continuous. Gender has 2 categories. Yes, it has 2 categories in this case. So that's why there's no dummy variables below. I should have figured that. Experience is continuous. Remember, that's the number of years of experience. And then applications we'll put in as well. Okay. Now we're just going to do this in a very straightforward way, putting everything in at once and seeing what's what. So let me just go over here for a second and perfect. Sorry, I'm continuing to move things around on my screen to make this work. So we're going to do regression linear again, and we're going to put one thing in the dependent and then a bunch of things in the independent. And then we'll come down and we're going to check off even more this time than last time. And the one thing that we don't check off, I would check off anyway. So pretty much just check off everything under, well, almost everything under linear regression statistics, and you'll be in good shape. But let's start running. Okay, so yeah, okay. So we go under analyze. And I'm not going to go ahead and do, remember, I'm not going to go ahead and do anything a priori. I'm just going to jump in and do this procedure. So analyze regression, linear again. We've got employment status for dependent. We have applications for independent, which is fine, but now we're going to add age. Oops, it took applications away, so that's fine. We'll put in age, we'll put in gender, we'll put in experience, and we'll put in applications. If I wanted to look at race, I would not put in this race variable, I would put in these. And it's a little bit more complex to figure out what is what, but it is certainly doable. But we're not going to do it here, but if that winds up being your dissertation, it's a doable thing to do. Okay, so then under statistics, like I said, this says to click off these. I like the R-square change, so I'm going to click that off too. You don't have to, but it kind of is helpful. And so basically everything's clicked off except for this covariance matrix. And remember, there's really no harm in asking for extra stuff. I mean, at least for the most part, I can't think of any where there would be, but you know, it just kind of continues to crowd up what you're trying to look at. For plots, this time we are going to just get the histogram and normal probability plot and all partial plots. Oops. So we go to, so we'll say under plots, let me get rid of this and get rid of this. That was from the last one. We're going to basically have our histogram on normal probability plot and produce all partial plots. And then we click continue again. And then I believe we're going to save some stuff too. And we're going to save the unstandardized, the cooks, and the leverage values, the studentized and the studentized deleted. So lots of fun stuff here. And like I said, even if you just went for the basic stuff, you'd be okay. This is just giving us a little bit of experience in if you were running this for, you know, in a way where you needed everything, what you would check off. So I think we said the cooks, the leverage, the unstandardized, studentized deleted. Yeah, that's everything. Okay, so then we click continue again. And is that everything? Yes. So then we're going to click OK to run this. And I'll show you where we're starting just because I left the other one there just in case you guys want to like look at it later or something. I thought I wouldn't delete it. So yeah, we're starting right here. Okay, that's everything we just started with. So we start off with some nice descriptives. We're given some means, some standard deviations for these different variables. That's potentially interesting for employment status, age, experience, and applications. It's obviously not very helpful for gender for a categorical variable. Then it goes ahead and gives us some nice correlations, which is just a little bit of a hint. If I look at the correlation between employment status and age, gender, experience, and applications, you know, like I said, it's just a little bit of a hint of what we might what we might be seeing as we push forward. Okay. Now, our R is only a little bit higher than what it was before. And our R square is just a touch higher than what it was before. So anytime that you add more to an equation, to a model, you're going to capture just a little more variance. However, maybe not enough to make it worthwhile, because look at our adjusted R-square. See, remember it was before 0.900? Now it's 0.898. It went down a little bit. Why? Because it's adjusting for all those variables in the equation. So not sure it was really worth it to put in all this other stuff, but let's look and see. Here is the ANOVA, same as before. I mean, same setup as before. And here's our DF of 4 and 89.
Wait, can you
So-
re-share your screen?
Oh, I'm sorry. I always forget to switch. Thank you for telling me. Yeah, so let me go back up then. Here is the R, which is just a touch higher, R-square, touch higher, adjusted R-square, a little lower. Here's our Durbin-Watson, 1.687, so we're still okay with the Durbin-Watson. But we weren't going to look at assumptions anyway, so you can ignore that, D Durbin-Watson. Okay. For the ANOVA, as I was just saying, still a very healthy F, still a very good significance value. P is still less than 0.001. And if I click in here, notice it is like slightly less significant though. I mean, very slightly, but still it is. And the reason for that is we have more DFs, more stuff in our model to account for. So that's pulling it down just a little bit. Okay. Now we come down to the coefficients. And this will be pretty much the last part we look at here. I'll double check, but I don't think there's really anything else we're going to look at. So here is our intercept at the top, 87.887. Remember, that's the one we don't care too much about if it's significant or not. The others we care about because they're independent variables in our model. So let's look. Age, not significant, 0.386. Gender, not significant, 0.463. Experience, not significant, 0.443. And applications remains very significant at P less than 0.001. So now, I don't know if we would really, in a real situation, leave everything in the model, but let's pretend we are. Let's pretend the literature says, well, really age, gender, and experience are the most important things. And you're trying to show, no, it's the number of applications. So it's important you adjust for these other things. So if we pretended we are in that situation and then you wanted to do some prediction, what we could do is we could say, okay, for a 30-year-old who is female, and I forgot which one is female and male in here, but I'll check, with 10 years of experience and putting out let's not make it that high, putting out 20 applications, what would their expected employment status be? So we would plug in those numbers. We would say 87.887 plus 0.096 times 30 years old plus 0.991 times, I can't remember, let's pretend 0 is female, times 0, plus negative 0.152 times 10 for 10 years of experience, plus negative 2.904 times 20. Whatever we got for that, that would be our predicted employment status for that individual. Okay, so primarily here, I mean, I guess this is a kind of what we were getting at before. Primarily here, we're looking at these significance values here on the right. And these betas, or B's, I should say, excuse me, on the left, if we're doing prediction. Okay, that's primarily what we care about. These 95%, I should have noticed this noted this with the simple linear regression as well. The 95% confidence intervals are nice as well if you are interested in talking about that. But I don't think that even the one example on there gets into that. And the rest of this, we don't really, for our purposes, we're not caring too much about. So let me come back here. So I'm trying to think if there's anything else. The only thing I didn't run through, which I can, is I remember in the lecture I showed you how you can do a prediction using SPSS, and it was you had to do a little bit of funky syntax stuff to do it. And I said I think it's easier to do by hand than that way, but you know, we could explore how you do it the other way too, if that's something you are interested in. So just let me know if you want me to go through that. But other than that, I think we pretty much covered how you would run the simple linear regression, how you would run the multiple linear regression. I talked a little bit about writing the simple linear, but I talked about that more in the lecture too, along with you know, using layered primarily there. And then for the multiple linear regression, in terms of write-up, I pretty much went all the way with the layered one without the assumptions, except I said we should do, you know, for the homework, you should do one prediction just to make sure you're okay with it. So you get to choose whatever factors, whatever you know, values for the variables you'd like. Okay, so let me know if you have questions. Okay. You can continue to chat them in or speak up or whatever. I'll just say that, so what we've got left today definitely is the 2 presentations. And then if we'd like, we can talk through any questions you might have about prior material, or, you know, or you can always email me or set up a time with me to do that too. So that's up to you.
I have a quick question about the exam.
Of course, yeah.
Next week. Well, actually, I have 2 questions.
Yeah.
I don't know how useful it would be for this exam, but are we still able to have like the one sheet of paper with notes on it?
Oh, yeah, of course. Yeah, same deal.
Okay, and then for homeworks 5, 6, and 7, those were the ones we did after exam 1. Can you post like solutions for those?
Yes, so I was going to actually ask you about that, so I'm glad you brought that up. So because I'm so far behind in getting that back to you, and I do apologize, I'm going to give you guys a choice. And I'm going to make this, actually, I'm going to make this bigger so I can see you guys. I'm going to stop my share, actually. Hang on a second. There we go. Now I can see everyone. So here's the choice. I know you're all working hard on these examples, and unless I see that, you know, see something crazy, which I just don't expect to see. How about I propose the following? I will, for 5, 6, and 7, for those 3, I will give you a protocol, like how it, what's the word I'm looking for? I will give you a solution to each of those. And I will give you all like just the full credit for having completed those and given your good effort. Alternatively, I can go through and give you individual feedback, but if I'm doing that, I'll go ahead and grade. I'll go ahead and grade them. So that's the choice. And
I'm going to say option 1 sounds great.
Option 1 sounds great. Okay. Any others for option 1? Ooh, there goes the thumbs. Okay, I think we have a majority. Yeah, okay, we do. Okay, I'll do option 1 then. So let's do that for 5, 6, and 7. I will give you some solutions and you will get credit for having, you know, having done those. And I will get to those ASAP, because I know you would like to have those so you can, it would help you study for the exam. Let's see, what else? Oh, okay. So I was gonna recommend we take a little bit of a break maybe. Come back, do the 2 presentations, and then if there's more you want to talk about, we can talk about it then. Sound okay? Okay. All right, perfect. All right, how about 10 minutes and we come back? Let's do that, and I'll see you in 10. Hi, we all back? Yes. Yes, yes. Okay. Perfect. Okay. So I wanted to put something out there as an offer to you guys, and you can think about it. But I know I mean, I don't know if you've gotten around to start prepping for this exam. I would certainly understand if you haven't, you had other stuff. My point is that if you would like to do like an, probably no more than an hour, but an hour either on, I think I can do either Sunday night or Monday night. I would be happy to do that with you guys. I want to make it fair though, so if Monday night leaves someone out who would otherwise want to participate, let's do it, let's do it if, when it works for everyone. But I did want to put that out there if you're interested. So think about it for a little bit, maybe while we do the presentations, and then maybe let's come back around and make a decision if you think that would be helpful to be able to, review, ask some questions, those sort of things. We can still do it tonight. I'm perfectly fine with that. I just wanted to put that out there because maybe it would be more helpful after you've had some additional time reviewing the material. So I'll put
That's
that
really helpful. What time on Monday night were you thinking?
I am free. Sorry, let me double check this. On Monday, I'm actually free after 3 o'clock. So it doesn't even have to be Monday night. It could be Monday late afternoon. Like it probably no earlier than 3:15, but yeah.
I would need after 5:30. I have 2 clients on Mondays.
Okay, till 5:30. We could do that. We could do something at like, let's say 6 o'clock. Does that work for everyone?
Yeah, that would be great. Thank you so much.
I can't do Sunday or Monday, but could you record it so that we can look at it?
Yeah, I can definitely do that. That makes sense. Let me record it. Yeah, definitely. And if you want to like submit questions beforehand, I can like answer them in real time and you can hear the recording. So for anyone else who would like to participate, does Monday 6 o'clock work? Or you're happy to listen to the recording? Does one of those two options work for you? Okay. Okay. All right, great. Let's do that then. So we'll plan on Monday 6 for an hour. And I will make a quick note of that before I forget. Monday 11/16, 6 p.m. Okay, yep, you got it. Okay, so let's get on with the presentations. Let's go ahead and yes, I will record it. Oh, am I still recording now? Yes, I'm still recording now. Okay, so yes, I'll record that too. So let's go on with the presentations. Let's start with simple linear regression. And that was,
That's me. Can you
that's
hear me?
you. Okay. Are you ready?
I am. Let me just share my screen.
Okay, perfect.
Okay. Can you all see this? Okay. So I'm reviewing the article Sleep Quality in Cigarette Smokers, Associations with Smoking Related Outcomes and Exercise. And the test I'm reviewing is the simple linear regression. So the purpose of the study was twofold. They were looking at the association between sleep quality and smoking related outcomes, while also looking at how change in exercise levels relate to changes in sleep quality. And the study was conducted over a 12-week period. They hypothesized that there would be an inverse relationship between sleep quality and smoking related outcomes. and a positive association between changes in exercise and changes in sleep quality. So they used a couple measures for the smoking outcome and habits. They measured how many cigarettes each participant smoked per day for 7 days before they came to the clinic. They measured the participants' psychological dependence on nicotine. They measured their withdrawal, and they measured their urges. And then sleep quality was measured by the Pittsburgh Sleep Quality Index. And basically, the higher you score, the worse your sleep quality is. And they used the insomnia severity index. And then the exercise levels were measured by a Fitbit Flex that they had the participants wear. So for the first 5 results, these were the hypotheses. Basically, that the amount of cigarettes they smoked per day would not predict poor sleep quality. The nicotine dependence would not predict poor sleep quality. Withdrawal scores would not predict sleep quality. And then the different subcomponents of the withdrawal scale would not predict sleep quality. So for the first part of it, they found that for every point that this PSQI score increased, the smoking urges scores also increased, and each factor on the questionnaire increased as well. The withdrawal scale total score increased, and out of the 7 items, 5 of them also increased. And for every point that the insomnia index increased, the withdrawal scale total score increased, and all 7 of those items increased as well. And the questionnaire for smoking urges, the second factor, increased, but every other result was not statistically significant. And here is the table to describe that. So everything with a star is the significant p-values, and everything else was not significant. And then for the relationship between exercise and sleeping, they initially ran a Wilcoxon t-test, and within subjects, Wilcoxon ranks test, and then they assess the association with simple linear regression. And they found that for every 10-minute increase in minutes spent in light activity compared from baseline to the 12th week, they found that the sleep quality score went down. And for every 10-minute increase being fairly active, they found that the score went down a little more. And every other result was not significant. And here is the table. So based off the results, we know that the p-value for cigarettes smoked per day, nicotine dependence, and the anxiety some subcomponent of the withdrawal scale were not significant, and therefore we failed to reject those the null hypotheses for those. But the total withdrawal scale and the irritability subcomponent were significant, so we can reject the null for those as well. I think that the test was appropriate for what it was measuring. I think it was more appropriate for the smoking and the smoking related outcomes and the sleep quality. As for the exercise and sleep, I wasn't really sure. I'm not well versed in the difference of the test and what it's good for and what could be better suited. I just felt that they went through so many steps to get to looking at the association. I was a little bit confused on that. So my question was why could they not just use the Wilcoxon results to look at to compare them? That's it.
Great, thank you very much. I just had one quick question, and it was about that table 2. It was really bugging me. And did you notice how like you had some results that were true for the PSQI, but then they weren't true for the ISI? You know what I'm talking about? Or was it the other way around?
No, are you talking about, because the ISI, all 7 of the items were significant, and then with the PSQI, only 5 out of 7 of them were. I'm gonna try and share my screen again.
Okay.
Oh no. Can you see anything?
Now I can. Yeah, table 2. That's the one I was interested in. Because yeah, for the PSQI, the change in daily minutes and the change in daily minutes for lightly active and fairly active. Oh, I see. Yeah, those 2 came out, but not for the ISI. So I just thought that was kind of interesting, right? That you didn't really get much out of the ISI for this table. Is that right, or am I?
No, yeah, you're right. They didn't find anything significant with the insomnia index, which is why I didn't know why they couldn't just look at, like, just compare the changes, and I don't know why they had to look at the association again.
Right. Considering, yeah, I hear your point on that. That's really interesting. I think that's a good point too. So yeah, that just kind of, I think we're on the same page with that. That sounds, you did a really nice job. Thank you. And let's move on to multiple linear regression, please.
Hi, that's me. Hold on, I'm gonna
Okay.
pull up the PowerPoint.
Okay.
Can you see the PowerPoint?
Now I can.
Okay, cool. Okay, so the title of the article that I had is The Effects of Parental Warmth on Adolescent Delinquency in the United States and South Korea Across Cultural Perspective. And I did it on multiple linear regression. So quick summary of the article is that they found a lack of cultural differences in levels of delinquency and its association to parental warmth in the research database. Due to the differences between individualistic cultures and collectivistic cultures, they believed that American adolescents are more likely to engage in delinquent activities than Korean adolescents, as well as parental warmth being less salient for Korean adolescents than American for delinquency. To collect their sample, they looked at AdHealth and KYPS, which AdHealth was for the US and KYPS was for Korea. And then they collected data in 2 separate waves of adolescents. And also in the 2 separate waves, it was that they were surveyed at one time point and then surveyed again 1 year later. The authors believed that in order to answer their research questions, they would use 3 sets of analyses, which were level of delinquency and protectiveness of parental warmth on delinquency for American teens, and then also for Korean teens. And then the third one is cultural differences would be associated with parental warmth and delinquency between America and South Korea. So their hypotheses that they proposed were that levels of delinquency will be higher among American teens than Korean teens. Parental warmth will be negatively associated with adolescent delinquency in both countries, and the effect of parental warmth on delinquency is stronger for American teens than Korean teens. So the authors used multiple linear regression to look at their results because they were looking at a continuous dependent variable, but they had a ton of independent variables that they were looking at, and they were interested in seeing which of the independent variables would affect the dependent variable most significantly. So their continuous their dependent variable was adolescent delinquency, but they had a lot of independent variables, including gender, country, parental education level, and I think SES too, if I'm remembering correctly. Oh, so I have it here. Family structure, not SES. So I also wanted to note that parental warmth appeared to be a dependent variable also, but I think it was mainly an independent variable. So they did use t-tests to find the mean levels of delinquency, but they used multiple regression of parental warmth on delinquency in the American sample, which showed parental warmth was significantly negatively associated with delinquency, and girls reported lower levels of delinquent behavior, and teens with parents with a college degree or higher reported lower levels of delinquent behaviors as well. And then for the Korean sample, parental warmth did not relate to delinquent behaviors significantly, and the other covariates like gender and parental level of education weren't significantly associated either. And then when comparing country to parental warmth, delinquent behavior was more protected by parental warmth in the American sample than the Korean. And the interaction between the covariates like the gender and family structure and parental education level had no significant interactions. So due to those results, we would reject the null for the hypothesis that levels of delinquency will be higher among American teens than Korean teens. We would not reject the null for the hypothesis of parental warmth being negatively associated with delinquency in both countries because it was only significant in one country, America, and not Korea. And we would also reject the null for the hypothesis that the effect of parental warmth on delinquency is stronger for American teens than Korean teens. Just one quick concern that I had with this article was using self-report for testing delinquency. I think they probably could have used a better way. Kind of the main things they pointed out was that for the Korean teens, they could have been underreporting their delinquency because they wanted to present themselves in positive ways to authority figures, which is consistent with that culture. And then one thing that I thought of was that some kids might just not be truthful about delinquent behavior because they're concerned about getting into trouble, or also they might not see their behavior as delinquent, like even though it might be, they could just kind of think that it's okay to be doing it. And that is all I have.
Thank you very much. Very nice presentation. So I have one question for you as well.
Yeah.
Did you catch if they were using the same measure for parental warmth in both countries?
They were using the same measure, but for the US, it was 2 questions. One was parental warmth with mom, one was parental warmth with dad. And then for Korea, it was only parental warmth for dad.
Okay, interesting. So when they put both of those in, so when they put both of those in that one model, if you remember when they included country and then they included the interaction between country and parental warmth, I believe, that was a no-no because the measures didn't match. In my opinion, I think that would have been a no-no.
Well, yeah, and I thought that was really weird too, because I think they were trying to make it consistent with Korean culture.
Right.
But with that, the measures were different, so they're going to get different results.
Exactly. Yeah, you're right on it. Yeah. So I was just curious about that because I thought there was something askew with that. So anyhow, but that's just good awareness for going forward, with everything. It's important that your measures match up if you want to add them all to the same model. So yeah, anyhow, very, very nice presentation. Thank you. And thank you both. Very nice presentations. Do you guys have any questions you would like to ask of me? As far as I'm concerned, I think we're set for the day, especially considering we're going to meet Monday, but I'm here. I'm more than happy to answer any questions you have. You're good. Okay. Okay, I think we're good. Please feel free to hang back if you have a question. Oh, you're good too. Okay, please feel free to hang back if you just decided you have a question. Otherwise, have a great night And I'll probably, I'll send out a, how will I do that? I'll send out something for a Zoom meeting on Monday. So I'll just send it out to the group so we can do that Monday at 6. And then Lindsay, it's you I'm going to hear back from about the Thursday final.
Yep, I'll let you know tomorrow.
Okay, perfect. Thank you. And then last question, we did talk about Thursday, 12/10 at 10 a.m. I just want to make sure we're not shortchanging ourselves. Like, when's the next thing that then comes up for somebody? Like, does someone have something?
I just can't do anything Thursday after like 4.
Oh, okay. That's fine. We're not going that long. No, I just wanted to make sure we weren't like, someone didn't have something at 11 or 11:30, just to make sure we have enough time for that, Perfect. Okay.
Sorry,
Any
I
other-
was just gonna say I have a client at 1, but
That should
that's,
be fine.
yeah.
Yeah, that should be fine. That should be fine. And I'll probably, if this works out for 10, maybe I'll even put out the option you can start a little earlier if you're concerned or want a little extra time. That's not a problem because as we'll all overlap as long as everyone else kind of shows up by 10. We'll figure it out. But you should be fine. Anyhow, any other questions, please hang back. Other than that, have a great one, and I'll see most of you on Monday.